Good morning, everyone. Today we are going to start a new chapter that is nuclear atom. First topic of this chapter 5.1 nuclear atom in atomic physics. So learning objectives of today's lesson, I can explain structure of an atom, I can analyze the electron shell rules, I can differentiate between atomic mass and atomic number. So today we are going to discuss about the structure of the atom. This chapter is related linked with the chemistry, okay? So let's start. First of all, what is atom? As you know that atom is the smallest particle, okay? And it before this you have studied that atom is the smallest particle that is indivisible. But remember this thing that it is not indivisible. First, you maybe in the lower classes you studied this, but remember this thing. Later on, scientists now research that no atom is not indivisible. It consists of more small particles known as electron, proton, and neutron. And now in the latest, now the research showed that even electron, proton, neutron also consist of subparticles that you'll study in the 11 and 12 IB. Okay, so here we will just discuss this first the structure of the atom. So here is the structure of the atom. You can see at the center of the atom there is a nucleus consists of positive charge. Okay, so it means the nucleus is positively charged. You can see this yellow ball shows positive charge. So positive charge means this is proton. Okay, and this orange color ball, you can see these are neutrons. You can see there is no charge marked on them. It means that these are neutral, no charge on them. So the atom consists of the nucleus, and these are the shells, orbits around the nucleus. And you can see in the orbits, small electrons are there. These negative charges are electrons. So it means atom consists of three particles: protons, neutrons, and electrons. Protons and neutrons both are inside the nucleus, and electrons are orbiting around the nucleus. And proton has positive charge, electron has negative charge, whereas the neutron is neutral, no charge on the neutron. Okay, you can see as I explained. So remember this is because at the center, all the particles concentrated at the center, because protons and neutrons are very close at the center, so whole the mass of the atom is in the nucleus. Electrons are far away and they occupy large space, but basically they are very small. Individual, you can see that electrons are negative charge, they are tiny, but they cover a lot of space. Why? Because they are far away from each other. That's why they occupy a lot of space. Okay, there's a lot of volume they occupy. Okay, so big volume they occupy, it means that this atom is big. But remember this thing, there is a big space between them. You can see there's this big space, but at the center there is no space, because protons and neutrons are concentrated at the center, very closely packed, whereas electrons are orbiting in the around the nucleus, but far away. There is huge distance between them, so that's why they occupy more volume. So practically, electrons' mass is negligible, very, very less. Okay. See now, this table shows that proton, positive charge, neutron, zero charge, electron, negative charge, and proton and neutron almost equal mass, but electron mass is very, very less. You can see 1 over 2000 means very, very less mass. Okay, now electron shell rules. What are the rules for the electron shells? Remember this thing, these shells are where the electrons are moving, orbiting. The first shell is the closest to the nucleus. It consists of 2 electrons. More than 2 cannot stay here. Only 2 electrons can occupy this shell. Whereas in second shell, remember this, I am telling you that maximum means that 1 electron can stay here. Remember this thing. But in second shell, maximum number of electrons can stay in second are 8. More than 8 electron cannot stay in the second orbit, and as well as in the third orbit, and so on. See now, there is more configuration that we will not discuss here in detail. 1s2, 2s2, 2p6, and some shells are there that we are not going to discuss here. That maybe you will study in the chemistry. So here we discuss the main shells. So main orbits. In first shell there should be 2 electrons. Okay, and second shell there should be 8 electrons. And remember, the last shell should also have the 8 electrons. Last shell. If third one is the last one, so it means there should be 8 electrons in the last shell. So electrons are happy, remember, happy in the full shell. When shell is complete, see in this shell, 1, 2, 3, 4, 5. 5 electrons are there. So this atom is not happy. Why? Because there is a space. More electron can come inside. So that's why it's, and you can say, uncomfortable, not happy over there, not stable. So if atom, you want to say that atom is stable, so that it means that its outermost shell should be completed, almost full. Okay. Now, so how do you know how many electrons, protons, and neutrons there are? So for this, we will go towards the periodic table. Maybe you know about the periodic table. So in periodic table, if you will see the elements like this, it's written over there, the numbers with the elements. So this Na is symbol for the sodium. So you can see the numbers 23, 11. So the smaller number is always shows number of protons. Okay, so it means in sodium there are 11 protons. Okay, so it means that 11 protons are there. So this is also known as, these protons are also known as atomic number. So this is atomic number. And this larger number is always known as mass number. Mass number is basically proton plus neutron. Proton plus neutron is mass number, and only proton is electron. Only protons are atomic number, and proton and electrons are always equal. I hope it is clear. I will repeat now that atomic number means number of protons. Okay, so this smaller one is atomic number. Bigger number is known as mass number. So mass number means proton, this proton 11 plus neutron. How you will find the neutron? Say this 23 minus 11. So if you will subtract 23 minus 11, so 12. So it means that in sodium there are 12 neutrons. So 12 plus 11, 23. This is mass number of sodium. Okay, so this is mass number. Mass number is total of proton and neutron. Sum of proton and neutron is called mass number. Atomic number is only number of protons. And in bracket you can see it is written electrons, because electrons and protons are always equal. Always remember, electrons and protons are always equal. That's why overall atom is neutral. Why? because protons, for example, in sodium, there are 11 protons. So plus 11. And there are 11 electrons, minus 11. So plus 11, minus 11, 0. So overall, sodium is neutral, no charge on the sodium. So you can see here, the atomic number tells you how many protons there are. This also tells you how many electrons are there, because I told you that protons and electrons are always equal. To get number of neutrons, just subtract atomic number from mass number. So this number, if they ask in the question, that's how many neutrons are there, just subtract mass number minus atomic number. That's it. You'll get the number of neutrons. So mass number is always the biggest number. As I told you, here 23 is the biggest, so it is mass number. And in mass number is always roughly double the atomic number. Roughly, see, 11 double 22, so almost double. Okay. So mass number is also known as nucleon number. Why? Because in the proton and neutron both are inside the nucleus. So mass number is basically sum of proton and neutron. This proton and this neutron both are inside the nucleus. Proton plus neutron, both of them are inside the nucleus. So when both are inside the nucleus, so that's why their name is also known as nucleon number. We can also call it nucleon number. And mass number is represented by this symbol A. Don't forget this thing, that mass number is represented by symbol A, whereas atomic number is represented by Z. Okay, so atomic number is represented by Z. So this equation we can write in this way. See, if in general form X, any element, here A, and here Z, means mass. A is mass number, okay, and Z is atomic number. And if you want to find the neutron, so neutron N is equal to A minus Z. You can make this equation. N equals to A minus Z. This is formula for the neutron, to calculate the neutron. Here you can see, just like nucleon number, atomic number is also known as nuclide notation. Okay, and each different type of atom is called nuclei. So this is the way with which you can write any element. Clear? Okay. Now here is a chemical equation. You can see that this is uranium. When uranium alpha particle emit from the uranium, this is uranium 9238. So 9238 means what? This is mass number, this is atomic number. So if you want to find out how many neutrons are there in the uranium, so you write 238 minus 92, 146. So it means number of neutron 146 in uranium. Okay, so when alpha particle emit, alpha particle, remember, is helium. Helium is called alpha particle, 2He4. So when helium will emit, so it will form thorium, thorium and helium. So this is chemical equation. Now important thing here, see now, whenever you are making any equation, you should know that equations should be balanced. Balance means that law of conservation of charge should be applied, should be valid. How you will calculate? See, mass number, this, you know, this portion and this portion. This is called a reactant, mean they react, and here the product, outcome out, this is product. So charges on of reactant and product should be always same. Means on reactant protons are 92. So you will see how many protons there. Atomic number 90 plus 2, 92. Mass number is 238. So it should be also 238. 234 plus 4 to 38. So this equation is correct. If there is anything missing, means proton missing or neutron missing, so this equation will be wrong. Is it clear? Okay, so that's it. So this was just general introduction. So this is the basic concept which I gave you today. So hopefully you have done this. So inshallah, we will go ahead in the next lesson. We will discuss more about the nuclear reactions. Now we will discuss. Okay. After this, thank you very much. So see you inshallah in next lesson. Thank you. Bye bye.